Alright, so now we are going to be doing graphing quadratic functions. So how do you graph a quadratic function? For a quadratic function to be graphable, it has to be either equal to f of x, which- or just equal to y. Now, if we have x, y is equal to x squared, how are we to graph this? So, make your grid. That's a very bad grid, I'm sorry. So, the basic shape is always going to be a parabola, so just make that a bit straighter. So, at the top, it's going to go straighter and straighter until at infinity it's parallel. There are two parallel lines at infinity. But what if there's other stuff, like, say, x squared plus 4x plus 3. What are we going to do here? So, what I like to do here, just to erase this, what I would do here is put this into the form which is good for the quadratic equation, which is this one. So this one would be squared for -1. This is equal to this, right? Yeah. So what this gives us is this is the y value, but remember with quadratic equations you need to flip it, so it's going to be -2, and this is the no, this is the x value, this is the y value, so -2, -1. That is the vertex. So in our grid here, we have -2 here and -1 here. So that is the vertex. And another value is the coefficient of this. So if it's nothing, then it's just going to be a normal curve. However, if this was 2, say, then what's going to happen is, let me just erase this. The the vertex is going to stay the same, negative here. However, it's going to be a lot thinner, like woo, woo. And the higher this gets, by like 10, it's gonna be pretty thin. Like and if this was negative, then what do you think's gonna happen? What's gonna happen is same vertex. Whatever is here is always whatever is these two numbers is always gonna be the vertex, except now it's upside down. Yeah, now it's upside down. So if it's negative, it's upside down. Now, have you ever heard of the discriminant? We're gonna get into the discriminant later. So, if and also to find the y-intercept, you can. There's another easier way to find the y-intercept. You can put it into the form you two factors, two brackets, the form in which it's you can solve it. You can't solve it though because this isn't equal to 0. it's equal to y. So these are the y-intercepts. -3 and -1. That is basically all you need to know, actually. And if it's not like perfect, this is not like this. If you can't put it like this, you can just do this and sort of estimate, fake it till you make it. There's a lot of other values as well. For example, the discriminant, if it is negative, then the discriminant, which is given by b squared -4ac, if the discriminant is below 0, no, above 0, equal to 0, or below 0, there are different scenarios. So in the top scenario, it is above 0. Above 0, it has two x-intercepts. So something like this. 1, 2. If it is below 0, no, if it is equal to 0, then it only has 1. How does it only have 1? Well, it just touches the thing like this. And if it's less than, then it'll have no x-intercepts. It'll just be over the line. That's enough for now. I'll get into more detail next video, including I'll try and include maxima and minima if we get that far. Thanks, guys.